Assalamualaikum and hi. On this video, I will present my final year project proposal. The title of my final year project proposal is Comparative Study of Various Open Source Software for Particle Image Velocimetry PIV Analysis, a test case in cylinder tumble flow. This project is produced by me, Muhammad Amiruddin bin Zamrry, and my supervisor, Muhammad Syahar bin Muhammad Shawal. The content of these presentations are segregated into 7 different segments. First, introduction. Second, literature review. Third, problem statement. Fourth, objective. Fifth, methodology. Sixth, expected results. And the last segment is Gantt chart. Now, I will start this presentation with the first segment, introductions. What is PIV? Many studies have been done in particle image velocimetry (PIV), and its functionality has gained tremendous acceptance as a legitimate field measuring technique for determining velocity fields. Particle image velocimetry (PIV) has been around for many decades. A lot of innovations and studies has been implementing the fundamental of PIV system. It has progressed from research labs to industrial applications. PIV has shown to be a useful instrument for analyzing cylinder airflow. It is an excellent method for determining the instantaneous velocity field of a flow in a plane. In this new era of convenience, researchers and users demand more effective innovations in terms of both functionality and cost. Nowadays, the current PIV software are divided into 2 different categories. First, the commercial PIV software, and the second one, the open source PIV software. The commercial PIV software has been widely used by many institutions and researchers, but the broad application of PIV remains limited due to reliance on expensive commercial software for PIV computations and post-processing. The example of the commercial PIV software is Davis by Lavisions and TSI Insights. Thus, the existence of PIV open source software that applicable in a MATLAB like PIV Lab, OpenPIV and DigiFlow helps to tackle the financial issue. PIV Lab and OpenPIV are one of the open source software that applicable in MATLAB. The PIV Lab and OpenPIV provide a wide functionality in pre-processing, image evaluations, and post-processing features for analyzing flow field with decent results. The pre-processing, image validation, and post-processing are the typical process steps for digital particle image velocimetry (DPIV) analysis. The availability of open source software can significantly assist in solving the financial issues that have arisen as a result of the use of commercial PIV software that has been used for many years. According to Figure 1, the graph depicts the inclination of people interested in the application of open source PIV software. The gathered data are from the Google Scholar citation statistic of the PIV Lab towards user-friendly, affordable, and accurate digital particle image velocimetry in MATLAB research paper by William Chillig. Compared to the commercial PIV, there are numerous benefits that can be obtained by using open source software in analyzing flow field, since it is cost-effective, high accessibility, and user-friendly. Now we move to the next segment, the literature review. On this segment, I will brief about the previous study on PIV Lab and OpenPIV. I will start with PIV Lab. PIV Lab is specially designed for MATLAB by William Chillig and EasyJ Stamhuse. It can be categorized as a well-established open source PIV software. It is currently the most popular non-official toolbox and app for MATLAB. Many well-known researchers all over the world have made extensive use of this open source software. The analysis of running real soil interaction, the flapping flight of bird analysis, and measuring sand dune migration rates were some examples of researchers that were using PIV Lab. PIV Lab is designed for planar 2D PIV and was first released in 2010. Since then, 30 updates with new features or fixes has been released in response to user reviews and individual demands. PIV Lab is generally programmed in MATLAB, and the open source software requires the presence of the image processing toolbox to properly function. PIV Lab not only has a function for calculating the velocity distribution within image pairs, but it also has the ability to display and export multiple flow pattern parameters as an open source PIV software. To add more clarity, PIV Lab will estimate the vector fields by using a cross correlation between the provided image pairs, and a correlation matrix will be measured in the frequency domain, or also called as a discrete Fourier transform. On this slide, we can see the GUI of PIV Lab. The figure depicts the graphical user interface GUI of PIV Lab after loading some example data. The PIV Lab has been used by the researcher as the open source PIV software for the analysis of running gear soil interactions. The analysis utilized the contrast limited adaptive histogram equalizations, or called as a CLAHE, as its pre-processing filter, and it was set to 40 pixels. It was discovered that using a contrast limited adaptive histogram equalization filter with filter size of 20 and 40 pixels reduced the mean square error. Then, the next experimental setup for the analysis was the application of the fast Fourier transforms 64 times 64, 32 times 32, 16 times 16 pixel multi-pass sequence of integration windows. The reason behind this experimental image evaluation setup is a 3-pass PIV calculation with sequential IW sizes of 64 times 64, 32 times 32, and 16 times 16 pixels was thought to be a good compromise between accuracy and computation time. For the post-processing, the analysis of running gear soil interaction implemented the global and local filters to eliminate outliers. For the selection of kernel size in local filter, it should be acknowledged that larger kernel sizes result in higher computational costs because more calculations are required per vector. The missing vector then replaced by interpolation function to obtain a complete velocity field. Then, the study of flapping flights of birds has fully utilized the application of PIV Lab. This study used several pre-processing filters such as contrast limited adaptive histogram equalizations (CLAHE), intensity high pass, and intensity capping. The contrast limited adaptive histogram equalizations implemented because it capable to improve the contrast and enhance the detection of valid vector by 5%. Then, the advantage of using the intensity high pass is it able to suppress the low frequency background informations and give a better result on signal to noise ratio. For the implementations of intensity capping, the increased impact of bright particles can be reduced and enhance the detections of valid vector by 5%. The next study that using the open source PIV software PIV Lab is the study on measuring the sand dune migration rates. The researcher of this study chose the frequency domain fast Fourier transform as its cross correlations algorithm. When compared to direct cross correlation computed in the spatial domain, computing in the frequency domain improved computational speed. The cross correlation is computed on a series of windows with interrogation areas that reduce in size as the algorithm iterates. Every successful iteration will generate a high accuracy final pass results. Then, the study that using the PIV Lab was conducted at the Hydraulic Engineering Laboratory at University of Salerno. The primary goals of the study are to investigate PIV Lab's performance on granular materials with various optical properties and to test the code's multi-step capabilities. The study investigates 3 types of PIV setup: single pass algorithm 32 times 32 pixel, 2-pass algorithm 32 times 32-16 times 16 pixel, and 3-pass algorithm 64 times 64-32 times 32-16 times 16 pixel multi-pass sequence for integration windows. The results show that when compared to the 3-pass calculation, the single pass calculation significantly underestimate the flow velocity profile, particularly near the bottom surface. And it is worth noting, however, that the 2-pass and 3-pass calculations produce very similar velocity profiles, except for some residual disagreement near the bottom surface. And lastly, the chosen previous study on PIV Lab is the experimental of acoustic streaming phenomenon, which is flow caused by the acoustic energy absorption during wave propagation. The pre-processing was used to raw images before the image evaluation process to enhance the contrast, eliminate noise, and homogenize image particle intensities, and then avoid polarization of the cross-correlation function for larger particles. Aside from that, the study implementing the fast Fourier transform as its cross-correlation algorithm and selected 128 x 128 pixel interrogation window because of the large number of particles in the integration area corresponds to a high signal to noise ratio. Then the interrogation window will gradually be reduced until it reaches 32 x 32 pixel or 16 x 16 pixel. Depends on the circumstances. For the post-processing, the local medium filter, or also called as the local filter, and standard deviation filter, or also called as a global filter, were utilized. Next, the flow of this presentation will continue to the OpenPIV literature review. OpenPIV is a global scientific community that creates free and open source software that uses PIV analysis to extract velocity fields from images and a variety of post-processing methods to reveal the physics of the investigated flow. A platform for analyzing and post-processing PIV data. Originally, URA-PIV was created in 1999 by Alex Librazon, Roy Gurka, and Yuri Shavit with the help of MATLAB. After years of studies, Alex Librazon, Roy Gurka, and Zachary Taylor improved and updated the open source program, renaming it into OpenPIV. To encourage open science, the packages were created in Python and C++. The OpenPIV has been widely used by numerous researchers to study the flow field on unsteady aerodynamic, surface vortex mitigations, burst aerodynamics, and so on. OpenPIV has been demonstrated to be as accurate as a commercial software, TSI's Insights. And from this slide, we can see the GUI of the OpenPIV. The figure depicts the graphical user interface GUI of OpenPIV after loading some example data. From the test case study of burst aerodynamic, the velocity fields were measured using 32 x 32 pixel interrogation windows with 50% of overlap from the PIV weight data behind the bird. Then, the second type, peak to the second peak of signal to noise types, was selected with a signal to noise value of 1, and the value of 100 was selected for the outlier filter. The processing function like global filter, local filter, and interpolation will be automatically run by the OpenPIV software. The output will generate 5 types of data: x-axis coordinate of the pixel, y-axis coordinate of the pixel, the velocity of x component, the velocity of y component, and the signal to noise ratio. Aside from that, the OpenPIV was also used as the software solution to study unsteady aerodynamics, and the velocity data were generated from the PIV image pairs by using a standard fast Fourier transform cross-correlation algorithm. The selected integration windows for this study were 32 x 32 pixel with 50% values of overlap. Aside from that, the researchers for this study did not use any pre-processing, but the mean intensity of the interrogation window is subtracted to improve contrast for each interrogation window. For another implementation of OpenPIV, the parametric analysis of smartphone camera for a low-cost particle image velocimetry selected the interrogation window of size 128 x 128 pixel based on number of particles in each window. Then the researchers calibrate the data into a physical unit, meter per second, by taking meters per pixel and time steps as inputs. OpenPIV then computes a data file containing the calculated velocity values in the x and y direction for all the points examined. Then the interrogation window size of 32 x 32 pixel with 50% overlap of OpenPIV parameters was used in the study of estimate of turbulent dissipation in a decaying great turbulent flow, and the invalid vectors were removed using special filters such as mean, standard deviations, and local median. The missing vector after the filtering process will be replaced with interpolated data. Other than that, the velocity fields for the study of cyclone, anticyclone, asymmetry, and rotating thin fluid layers were obtained by using the open source PIV software OpenPIV. The experimental setup for the study are 32 x 32 pixel interrogation window size and overlap of 16 x 16 pixel, which is 50% of percentage. I will continue the presentation with the third segment, which is the problem statement. The main problem of PIV, broad application of PIV remains limited due to reliance on expensive commercial software, approximately more than $4,000 annually for PIV computations and post-processing. The cost of the system has been a major obstacle to the use of PIV in research. Research-grade system can easily cost $100,000 or more. As a result, they are inaccessible to a large number of researchers and students. Thus, for the solution, this project aims to explore the potential of the most popular open source software, PIV Lab and OpenPIV, in post-processing the two-dimensional PIV images. After that, we move to the objectives of this project. The main objectives of this project are segregated into three different parts. First, to develop post-processing procedures in analyzing PIV images using PIV Lab and OpenPIV. Second, to compute the velocity vector field of two-dimensional PIV images using the open source software, which is the PIV Lab and OpenPIV. And the last one, to compare the computed average flow velocity and pixel displacement error between the open source software and the best conventional processing software devised by Lovation. Now I will proceed this presentation with the project methodology. As you can see, this is the flowchart of the particle image velocimetry analysis. Initially, the in-cylinder tumble flow experiment and the synthetic image generation developed the raw images in double frame. The in-cylinder tumble flow experiment raw images gathered from Davis in IM7 file format will be converted into .mat file format. Then MATLAB software will be used to process and split the double frame raw images into a pair of single frame image. After the process of image conversion on MATLAB accomplished, the desired image pairs will be loaded into the PIV Lab and OpenPIV by converting the .mat file format into the tape image file format, or also called as a TIFF. Then, the PIV analysis starts from the pre-processing part after the image pairs has been loaded to the software. The purpose of the pre-processing is to develop a more conditioned image pairs for the cost correlation process. Several pre-processing functions provided by the both PIV Lab and OpenPIV softwares are utilized. The pre-processing in PIV analysis will utilize a function that takes care of the contrast of the image pairs. As example, the pre-processing features of contrast-limited adaptive equalization, or also called as a CLAHE, provided by PIV Lab is able to improve the image pairs contrast and improve the detection of real vector about 5%. Next, the aid in conserving the high frequency information from the existence of any particular illumination that will result to inconsistent lighting, also one of the advantages of PIV analysis pre-processing. The other reason for the PIV analysis pre-processing is to eliminate any contribution of correlation signal. The PIV open source software, PIV Lab, provides a feature named intensity capping that will lower the possibility of bright spots existence on the image pairs without eliminating the good sides of the bright pixel by simply reducing its weight. Then, the PIV analysis pre-processing helps to reduce the available noise on the image pairs before the image evaluation. Finally, the strong background signal from the uploaded image pairs can be eliminated by implementing PIV analysis pre-processing. After the image pairs has been pre-conditioned throughout the pre-processing, the calibration is needed to convert the pixels per frame unit into physical unit, meter per second, by entering the real distance, millimeter, and time step, microsecond. Then the cross-correlation process will be executed. The selection of the integration areas will be selected during the PIV image evaluation. To gain a better signal-to-noise ratio and great cross-correlation robustness, the larger integration areas are needed. However, a low vector resolution could exist as a drawback of selecting large integration areas. As an alternative, the data need to be analyzed in several passes, and the integration areas for the following passes must be reduced proportionally. Hence, the multipass fast Fourier transform (FFT) will be selected as the cross-correlation PIV algorithm for this study. The algorithm will generate the cost-to-find integration method. The next part of PIV image evaluation is the peak finding function to calculate the x and y axis separately for a well-exposed image pairs and image pairs that are exposed to extreme motion blur. Next, the PIV image evaluation provides a function that will repeat the correlation at the shifted areas and multiplying the resulting the correlation matrices. By using this function, it can aid to improve the detection of real vector and the estimation of its displacement. The next part of the PIV analysis is the PIV post-processing. The PIV lab post-processing consists of three important functions: data validation, data interpolations, and data smoothing. The data validation will gather information from vectors and filter the data using the velocity vectors. Then, it is able to limit the acceptable and unacceptable vector, while the existence of the global and local filter will aid to remove the obvious outlier vectors and the vectors that are inhomogeneous from its surrounding. Aside from that, the data validation process can aid in enhancements of the data because it has the capability to ignore the bright areas of images and filter the areas with low contrast. The outliers will be removed from undergoing all the processes. The missing vector should be replaced by using data interpolation. The final section of PIV post-processing is the data smoothing. The application of data smoothing can enhance the process of noise eliminations. One of the most effective methods of data smoothing in PIV analysis is by median filtering. Hence, the process of data smoothing can be done by enabling the local median filter during the post-processing. After the instantaneous velocity field decently developed, the process will continue to the data exploration. Prior to the process, the PIV lab and OpenPIV will compute the data to obtain the mean velocity field of the stationary flow and pixel displacement from the image pairs. The results of the PIV open source software, PIV Lab and OpenPIV will be compared to the commercial PIV software devised by LaVisions to determine the effectiveness of the PIV software. In order to reach a concrete conclusion, the comparative process will employ two distinct approaches. The first comparative method that will be implemented in all PIV software is a mean velocity comparison of the image pairs obtained from the in-cylinder tumble flow experiment. The effectiveness of the PIV open source software will be determined by comparing the results with the commercial PIV software in the comparative method. The second comparative method is by introducing the usage of the synthetic images as the comparison subject for the other PIV software. Synthetic images are images generated by the computer that can mimic the real-world image flow field. The parameters of the images can be set as desired with the aid of pure computation. Then, this presentation will be proceeded into the next segment, which is the expected results. The objectives of the project are relevant and achievable. Thus, the achievement of mapping the velocity vectors field or the flow structure of the in-cylinder tumble flow in each tested open source PIV software, which is the PIV Lab and OpenPIV, is expected in the end of the research. Aside from that, the project holds a huge potential to compute the instantaneous and ensemble average flow velocity for 50 cycles pair of images over a region of interest. The expected result is realistic based on the explanation of the PIV process in methodology. Then, the next reliable results expected from the outcomes is the computations and comparisons of the software effectiveness based on average flow velocity and pixel displacement error. Finally, the last segment of this presentation is the Gantt chart. The purpose of the Gantt chart is to plan the flow of the project properly. From the figure shown, it depicts the flow of my project planning. Before I end this presentation, I want to quote a phrase from Henry Petrosky, an engineer. Failure is essential to engineering. Every single calculation that an engineer makes is a failure calculation. Successful engineering is all about understanding, break, or fail. And thank you for spending your time on listening my final year project proposal presentations. And this slide is prepared by me, Muhammad Amiruddin bin Zamrry. And if you have any question regarding to the presentation, you can contact me throughout my email amiruddinzamri@outlook.com and my phone number 01979762994. Thank you.